Hey, what's going on, guys? Welcome to the channel. Today is a very special day. We are starting a brand new series called Unity Foundation, which is going to be covering all the basics and core mechanics you'll want to know if you're just getting started in the game development with Unity. Let's get into it. So for today's episode, guys, we're simply just going to be looking at ways to move game objects. So to start here, probably the easiest way to set a new position to a game object would be to simply write Transform.Position equals a new Vector3 position. And we're just going to go ahead and write this in the start method. That way, right when we play the game, we'll be able to see the position change. And if we go ahead and run this, we'll see that the game object does in fact move to the new position that we set it to. So this is only really useful if you need to, set your game object to a position and have it be there instantly. Say you're spawning some enemies and you need them to go to that position immediately, or you're moving the player to a new position. Maybe he went through a teleporter or something like that. But if you need let's say you need a more fluid movement, you need it to move to a new position over time, or even move in a direction over time, we can go ahead and do something else. So if we head back into the script, we're gonna get rid of that code and we're gonna go instead into the update method. And this is gonna be called every frame. So instead of writing transform.position equals, we're gonna write transform.position plus equals. And all that's basically meaning is we're simply gonna add to the position we're currently at every frame. So now we need to tell the game object which direction we want to move in every frame. So we're going to go ahead and do that by using a unit vector, and Unity already has some built-in ones that we can use. So now that we have a direction, we're simply going to multiply that direction by some numerical value, and that'll be our speed of the game object, and then we're going to multiply that by time.delta time. And if we go ahead and run this now, we can see the game object is moving in the forward direction, and it's based on the speed we gave it. So since we gave it a world space unit vector, Vector3.forward, the game object's always going to move in the same direction regardless of its rotation. So if you want your directions to be based on the rotation of the game object, we got to use something called local space unit vectors. So if you go back into Unity and you go into the top left, there's like this little icon. It should look like a sphere. And if you go ahead and click that, you can change it to local, and that way you can actually see the local directions. And if we head back into the script and just quickly change our Vector3.forward to Transform.forward, we can now see that the game object does move in the direction it's facing. And just a quick side note, using Transform.position plus equals and then your direction times speed, this can actually be changed to using Transform.Translate, and it'll take in the same variables. So now let's say you want to move a game object from point A to point B, and you want it to move continuously at a certain speed until it reaches that spot. We can go ahead and use Vector3.MoveTowards, which will take in your current position, the target position, and then a float. We're going to call it step, which is simply just speed times time.delta time. And now if we just set our target position, we can see the game object does move towards it, and once it reaches its target position, the game object will stop. Alright, next up we got Vector3.SmoothDamp. And the way I like to describe this one is it kind of acts like a spring. So the farther your target position is from your current position, the faster it's gonna move the game object to the target. And I think this smooth damp function works best if you're doing any type of camera work and you want it to remain really smooth. If you're doing like a third-person game, you're gonna want the camera to remain smooth regardless of how often the player's changing directions. It can get pretty jittery. So using the smooth damp, it'll really smooth that out. And if we run this, you can kind of see the game object is moving. As it gets closer to the target position, it's gonna start slowing down, and it'll actually never reach its target position. You can see like in the top left here, and that's kind of just how this function works. It'll continuously slow it down as it gets closer. Alright guys, so now if you want a game object to move from one position to another, and you know kind of exactly how long you want it to take to get there, then you're probably going to want to use Vector3.lerp. This one will take a start position, your end position, and then it'll take in your time elapsed divided by your duration. So for the time elapsed variable, all you need to do is say time elapsed plus equals time.delta time in your update method. And then for using Vector3.lerp, something to note is all you're going to do is say transform.position equals. You're not going to say plus equals. And then all you got to do is pass in your start position, which we'll set in the start method. We'll say start position equals our transform.position, and then our target position, and then simply time elapsed divided by our duration. And the duration, we'll go ahead and make that public. That way we can change it in the editor and see exactly how this works. Any type of movements you guys are doing that are based on time, this is definitely going to be what you want to use. Now, if you guys are looking to use the physics engine within Unity, you're going to want to go ahead and add a rigid body to your game object. And as you can see, we got a whole bunch of different variables we can mess with now. We're just going to go ahead and leave these as is, and we'll jump into the code first. So to start here, we're going to use a function called Rigidbody.AddForce. And what this does is you give it a vector3 direction for the force, and you just multiply it by a strength, and it'll apply that force. And it's also important to note that this function is only going to work if you have a reference to your rigid body. So you can see we have ours in the start method, but if you want, you can also make your rigid body a public variable and just do it right in the inspector. Now if we go ahead and play this, we'll see the game object does move in the direction we gave it, and we have our force multiplier, our force strength, and we can just go ahead and change that value and see what it does. So now if you guys are looking to use the WASD keys as a way of moving your game object around, we can simply set them in a vector3. So the horizontal axis is the A and D keys for left and right movement, and the vertical is the W and S key for forward and back. And the reason we set vertical in the Z axis is because our player is not going to be moving in the Y direction, which would be up. Instead, we're going to move forward in the Z direction, if that makes sense. So now instead of adding a force to the rigid body, we're going to go ahead and directly change the velocity of the rigid body using RBody.velocity. And we're just going to go ahead and set that equal to our move direction .normalized, and then we're just going to multiply that by our speed variable. And the last thing we're going to want to go ahead and do here is freeze the rotations on X, Y, and Z. That way when we're changing the velocity of our cube, it doesn't try to rotate. And if we play this now, we can see using the WASD keys that we have full control of the movement on this game object. And that's going to conclude it for this episode, guys. I hope you enjoyed. If you made it this far, consider liking, subscribing. And if you guys got any questions or comments, just leave them down in the comment section below and I'll be sure to check those out. But yeah, guys, other than that, hope you have a great day and I'll see you on the next one.